Hi, my name is Dan, and this video is one in quite a large series of videos in which I'm using DigitalWorks software to simulate a 4-bit CPU. And this has been done starting from the basic logic gates to building all the different components. And we're nearly at the end now, and we're putting the CPU together. So I hope you've been following along with this. I hope if you have that you've been doing it yourself. DigitalWorks software is free to use. There's a link to where you can get hold of it in the description down below. There's also in the description down below a roadmap of where we're going. Like I said, we're pretty late on in the sequence of things. Um, so yeah, I'm not going to apologize for the fact that I'm not going to explain everything that's happened beforehand before this video, because that's what the other videos do. Uh, but if you're playing along with me and making this thing, let's get going. So we've got to the uh, kind of the end game really, and we're putting components together to actually make the CPU. In the previous video, we put in the stuff that you can see on the screen already, which is mostly registers and memory and a few LEDs. And in this video, we're going to be putting in the ALU, the arithmetic logic unit. So it's not going to take very long. Um, However, I do just want to tell you that between the end of last video and the start of this video, I've done a little bit of tidying up uh, in the wiring that we've got. You'll notice this area here. I wasn't happy about the way it came out in terms of um, the wiring. It was a bit of a mess. This is looking much better. I haven't actually needed to move anything. I've just taken a slightly different approach, which is to connect the two address things together from the two memory banks, and then connect that up to the values here. You'll also see that I've made a few changes to the LEDs that I was putting in for the A and the B register particularly, but also for op. The op's not wired up yet because those wires are going to come round this way and link up to this when it comes down to the control unit. And we're going to pull out lines this way to get to the ALU from A and B. I've also moved the program counter a bit to the right just to give us a little bit more space there. So I hope that is all straightforward and reasonable. If you're playing along and doing this yourself, your layout might be slightly different, or it might be very different. It depends on how you've approached this. The layout isn't the important thing in some ways; it's the actual setup that's important. So anyway, as promised, ALU, and we've got our ALU that we made earlier. There's a whole lot of components here in the part center, which if you've been playing along, you should have the same set of components as me. So the ALU expects a values and B values. And do you know what? Looking at this, I think I'm going to do two things. The first of which is that I'm going to spin this so that it's on its side, so that we're actually going to connect the bus up down to this set of lines down here, because we've been running out of space on our main bus over there. And I'm going to do something else, which is a fairly simple thing to do, which is that I'm just going to take that label and put it there, and take that label and put it there. Oh, I've spun it. I didn't want to spin it. This is sometimes the problem with small annotations. So I'm going to reverse those two, because here's our A, and here's our B, and here's our bus. I'm going to slide it down a bit and leave some space so that we can get in. So this means the opcode's got to come round and into there, but that's not too much of a problem. It just kind of lines things up a little bit better. Which shall I line up? Actually, I'll do pretty much perfect lining up for B. So I'll pull it up a little bit so I can pull out from there, and then I'll need to route those round somewhat. So we need to, because we put it on its side, we need to be quite careful about getting these the right way around. So 0 is going to 0. I've just checked. And in fact, let's pull out this way so we can get our lines straight. I should have done that for the first one as well. Maybe needed to be slightly lower on that one. Yes, I'm not going to have quite the space that I wanted, so I'm going to need to angle these slightly. Or pull down the LEDs. Let's pull down the LEDs. I'm a little reluctant about that because that means that this, which is now B, is closer to the A register than to the B register. But never mind, we'll pull that down a bit as well. So let's do a little bit of tweaking. I'm getting slightly too obsessive about neatness here. There we go. And 0. So what am I going to do 0 first? I'm actually going to do... Oh, so yes, no, 0 is at this end. Oh, no, it's at the top. Let's cancel that. And I'm going to do 3 first because 3 is the one that's going to sit tight up to the ALU. Shift that across. Still looking relatively tidy, which is good. Wait until we get the control unit in and we get all the bus reads and output enables connected, because that's where the spaghetti really comes into play. That's just maybe a little bit too far out there. I'll just adjust that. There we go. I could obsessively change these a little bit, but I'm not going to bother right now. I might do later. And then we're connecting from the bus down to the bus. Right. Let's make sure we get this correct. So this is bus 3, which is this end, which comes down here and connects to the top one of these lines. And so we have kept that consistent with being vertical. That's because it's going into the program counter over there. So I'm going to go bus 3. And I know it doesn't look like it's connected to the bus because it's connected to this bit, but everything's connected together. I've just wired that last one up wrong. And I'm glad I noticed. Right, so the next thing we want to wire up is the opcode for this. And I'm just asking myself whether it would be better for me to wait until I've got the control unit in, because the opcode needs to go into the control unit as well. And the answer I'm going to give myself is no, I'm not going to do that. And I'm going to wire out of this. We've got an enable and a clear to wire into, but that's okay. We don't need anything tight up against that. So I'm just thinking about the space and where I'm going to put things. I might want to alter this later, we'll see. And there's yeah, a little bit wonky. I've not given myself a lot of space here, to be honest. Oh, and that's very tight together. Tight is all right, though. Last one. And at the stage, I can now wire in these. So let's go to that one. I've given myself enough space. I need to do them quite tight up against each other. Come on, attach. Ooh, slightly wonky. Never mind. There. Okay. So, is that everything that we need to connect in there? We've got output enable, which is going to come from the control unit. We've got our C out and our Z flags, which are going to go back into the control unit. We've got execute and clear. So clear is, we are going to have a general clear at some point, but I don't need that yet. So I think that's everything that needs to be connected up for the ALU. We're not at the stage where we can test this yet because we need everything in before we can do that properly. So in the next video, we're going to bring in the control unit, but that's it from me for now.